Hello, everyone. My name is Kevin Tarr. I am an iOS engineer, and today is day 22of Algorithms in Swift. So today we're going to be using our best friend from yesterday, called generics, to solve a problem dealing with numbers of any type, like this, or like this, or like this. We're basically going to be given a problem, given an array of numbers, and we have to find the sum of all the numbers combined. Okay. Now this problem was definitely more complex in the past with Swift because Swift had limited functionality to deal with numbers of any type. Swift recognizes integers, floats, and doubles to all be different data types, even though we as humans recognize them as just numbers. Um, so they hold different data storage and memory. So to solve a problem like this was definitely less straightforward. But now with the numeric protocol, it's become a bit easier, but emphasis on a bit. And we're going to find out how to solve this problem in a straightforward way. So let's begin. So our problem states, write one function that sums an array of numbers of any type. The array might contain all integers, all doubles, or all floats. And then we have some sample test cases here. The number 10, 20, 30 should return 60, obviously, because that equates to 60 when added together. Our array of doubles, 5.0, 6.0, and 7.0 should return 18.0. Our array of floats, 1.0, 2.0, and 3.0 should return 6.0. Okay, so again, as I was saying before, previously in the past, this problem was definitely one with extraordinary difficulty because, well, there's a lot of critical thinking. Let's not say difficulty. Let's just say a lot of critical thinking, because you had to create a protocol. Swift didn't have a protocol to handle this or handle numbers of different types. Swift recognizes integers, floats, and doubles will be of different types, completely different data types. Even though we recognize them as numbers, Swift recognizes them as different data types. Doubles hold 64 bits of memory, floats hold 32 bits, integers hold 32 bits or 64 bits, depending upon the device, but all of them are very different, even though all numbers are very different data types in Swift. So creating a function that can add all of them together definitely require you to create your own custom protocol and apply generics in order to be able to create a generic function that's able to be applied to any number type. Now Swift has come out with the numeric protocol, and that numeric protocol helps us a bit to solve this. This problem is still pretty challenging. It requires you to understand generics and how to use them in order to solve this. But if you understand generics, you could definitely solve this in a straightforward way. If you don't understand generics, functional programming is still your best friend, but God be with you. But since we do understand generics, we're going to use generics and we're going to use functional programming to solve this problem. So let's begin. So func, I'll call this add numbers. Want to make this conform to the numeric protocol. And then we're going to return a generic, okay? Now this is key right here. We're going to actually do something pretty clever here. We're going to create a variable and make it equate to 0. Now why do we make a variable equating it to 0 right here? Let's call this sum. Because 0 is a number that can be applied to any number type. We know that, well, first of all, 0 defines the fact that our generic is going to strictly conform to numbers only, okay? So it can't be applied to strings or anything like that. It's going to be applied to numbers. And what also is clever about this is that 0 can be applied to doubles, it can be applied to floats, it can be applied to integers. Integers, all those number types recognize 0 as part of their number range. 0 is consistent, it's universal. It's a universal number. So creating this sum helps us boil things down and for us to recognize that we're using number data types like doubles, integers, or floats, and we can apply it to any of those number types. With that being said, we just create a simple for loop and make add sum to the number that we're currently going over, and assign that to sum, and keep adding it to our sum value, and just return sum. And that solves our problem, believe it or not. So now we can add numbers of any data type. So we can add an array of 10, 20, 30. And that should give us 60. Boom. Okay. We can do an array of doubles right here. And just to show that this is explicitly a double, let's add a 0.1 to this. This should return 18.1. Boom. And we can do the same thing with an array of floats, explicit array of floats. Okay. Boom. And let's just make it explicit. Let's do 1.2. 6.2. Boom. Okay. So this solves our problem, and this can be applied to any number data type across Swift. Okay. Now, if you don't want to go through the whole for loop and you want to just impress your interviewer and solve this in a functional one-liner, we can do that as well. So instead of doing this whole for loop something, we just turn and call the reduce function. 0 plus. And that by nature sums every number up. And this was actually my solution before when this problem came up when we didn't have the numeric protocol. Reduce adds any number type up and conforms them into one, So this works. This is a 6.2. If we were to do the same thing with our array of doubles, 18. Let's make it explicitly show as decimal point. 18.2, and we do an array of integers. $60. Yep. So this solves our problem, guys. This is a beautiful functional one-liner. I like it because it's only 2 words, actually. Numbers dot reduce. Bad joke. Well, anyway, it solves our problem. So, guys, let me know what you think about this problem in the comments below. Let me know if you come up with an even more clever solution. This definitely involves generics. Again, sort of an advanced topic is Swift, but this problem is is a pretty straightforward way to understand how generics can be applied to multiple different number types or multiple different data types, which is kind of the point of generics, to create universal functionality of multiple different data types. Guys, thanks again for watching. Have a good night. Bye.